Hi, I'm Tom and I like dinosaurs, sheep and gambling. Now for the dinosaurs I'm actually a bit worried because, see, in those days it used to be quite hot. So didn't the dinosaurs get some bad sunburns? Now for the dinosaurs you could say they are big animals, so maybe it was a bit painful. But their predecessors used to be tiny unicellular organisms, and the sun emits high energy particles that can cause cancer and kill those animals. So life could have died out long before the dinosaurs even evolved. Obviously in those days they didn't have parasols, so they needed a different way to protect themselves from the sun. Turns out another way to block off solar radiation is magnetic fields. Conveniently, the Earth happens to have a magnetic field. Or does it? See, we don't actually know if the Earth had a magnetic field in those days. So scientists went out to search for rocks that are from that time. And they didn't find any. See, there are just not that many rocks left that are that old. But they did find some tiny pieces of rocks inside larger pieces of rocks that are as old as 4 billion years. And inside these tiny pieces of rocks, inside larger pieces of rocks, there are yet tinier pieces of iron. Now iron is magnetic, and therefore this mineral is appropriately called magnetite. Magnetite has two properties. First, it's kind of like a bar magnet that has a north pole and a south pole, or the other way around. And second, they're kind of like sheep. I like sheep. Sure, sheep stink a bit, but apart from that they are quite nice and peaceful animals. You often find them in valleys peacefully chewing along on some grass. If there are multiple valleys that are separated by a hill, then the sheep will just stay in whatever valley they happen to be. If you ever found a sheep on top of a hill, chances are that it would just look down left and look down right, and then walk down either way. A physicist would call this type of landscape an energy landscape with an energy barrier. And that this is the reason why magnetic particles stay magnetized in whatever way they happen to be magnetized. The valleys might be either at the same elevation or at different elevations. But to sheep this doesn't matter. Sheep don't climb. If they did, they would be called furry goats. For magnetic particles, if there's a magnetic field present, then one valley will be higher than the other. If there's no magnetic field, they will be exactly the same. So we all know from experience that on a warm, sunny day, sheep might happily jump around. Of course, the grass is always that little bit greener on the other side, so if a sheep just jumps high enough, it might just be that it manages to jump across the hill into the other valley. A physicist would say it overcame an energy barrier because of thermal activations, which is just a complicated way of saying a sheep jumped over the hill, or a magnetic particle changed its magnetization. Now the probability that a sheep jumps from the higher valley across the hill is a little bit higher than the probability that a sheep jumps from the lower valley across the hill, and physicists have equations to calculate this. Of course, sheep are actually very social animals, so you'll typically find whole flocks of sheep in any valley. And all of these sheep will happily jump around. So at any point in time, there will be some sheep jumping from this valley into that, and some sheep jumping from that valley into this. So the numbers of sheep in both valleys might change, until they reach a point where the numbers of sheep jumping from left to right is equal to the number of sheep jumping from right to left. A physicist might call this a thermodynamic equilibrium, which just means that the numbers don't change anymore. Now when the sun sets, the sheep will go to bed and stop jumping. This is actually what happens to rocks when they form. First, they are very hot, so the magnetic particles can change their magnetization. But eventually they cool down and the magnetic particles stop changing. Now naturally, if the two valleys are at the same height, then the number of sheep should be the same. But if the valleys are at different heights, the number of sheep should be different. In the same way, if there was a magnetic field when a rock formed, then the numbers of magnetic particles magnetized in that direction should be slightly larger than the number of particles magnetized in the other direction. Now the scientists that found these 4 billion year old tiny pieces of rocks inside larger pieces of rocks say that there are more even tinier iron particles magnetized in one direction than in the other, and therefore they conclude that the Earth must have had a magnetic field when life formed, giving those tiny unicellular organisms a cushy and safe place to live and evolve into dinosaurs. But there's still one problem. See, the sheep are actually jumping randomly. So we cannot be sure that if there was no magnetic field, that the numbers of sheep would be exactly the same. It's kind of like gambling. Imagine a gambler. He thinks red is his lucky color, so he goes to the casino. He goes to the roulette, he sits down at the table, and he takes his money and bets on red. Now the wheel spins and it's black. That was bad luck, he thinks. I'll just bet again. He bets on red. The wheel spins and damn, it's black again. He bets again on red. The wheel spins and oh my god, this is not his day, it's black again. He tries one last time. He bets on red, the wheel spins and it's black. So disheartened, the gambler gets up. He leaves the table and from the corner of his eye he sees the ball fall into a red pocket. Now as a scientist I kind of like gambling, but only if I know that I can win. Of course, if you only bet once, you either win or lose. If you play twice, you should actually win once and lose once, but it's totally possible that you lose twice or win twice. If you play 3 times, you might get black 3 times in a row, but chances are that actually you win at least once. If you play 4 times and you lose 4 times in a row, it doesn't necessarily mean that red just doesn't happen. In fact, if you went to the casino every day for a whole month, on average you would lose 4 times in a row twice. Luckily you would also win 4 times in a row twice. What if you played 100 times? Well, if you played 100 times and won 100 times, you will definitely find some big guys at the exit of the casino. Actually, even if you win only 90 times out of 100, you'll definitely meet those guys as well. And that is because on average you would have to play 1 billion times to be this lucky to win 90 times. Now let's get back to the sheep. In my research I calculated how many sheep you have to count, or actually how many magnetic particles you have to count, in order to be sure that the values are really at different elevations. Or in other words, to be sure that there really was or wasn't a magnetic field. And this number is about 10 million. Now those 4 billion year old tiny rocks inside larger rocks, how many particles do they contain? And the answer is about 10 million. See, these samples actually belong to the smallest samples that we can still use to learn something about the past magnetic field of the Earth. And therefore we can be confident that 4 billion years ago, when life formed, the Earth already had a magnetic field, giving those early life forms a cushy place to live and evolve into dinosaurs. I would love to finish the story on "they happily lived ever after," but they didn't.